Good afternoon, everyone. This is not like a food coma slot, but this is 1 hour after the bar opens slot. So let's have some fun this afternoon. My name is Christopher Penn. I am forward-looking things, looking forward. Awesome. I'm Chief Data Scientist here, and let's get into the actual presentation rather than spend time on bios. Every business, every single one of you is going to be asked for three simple things, right? From your stakeholders, from your board, from your C-suite. Make my business better, faster, cheaper. Your customers want this, your clients want this, your boss wants this, you want this as well. How are we doing at this? How are you doing at this? Generally speaking, let's take a look at the better first. As Dustin said this morning, we're creating a lot of data. This year, 2019, humanity is on path to create 40 zettabytes of data this year, which is an unimaginably large number. It's a number that doesn't even make any sense. How large is a zettabyte? Anyone know? Okay. How many people have subscribed to Netflix and watch Netflix? Wow, okay. Just make sure you're here, because it's most people. If you were to start watching Netflix 55 million years ago, and you didn't stop to eat, to sleep, to use the restroom, you would just be getting to 1 zettabyte of data usage today. That's how large a zettabyte is, and we're going to create 40 of these this year. Now, a lot of that is emoji and random political news and stuff, but in there is your company's data, your business's data. So when we ask the C-suite, what's going on? What do you care about? Pricewaterhouse asks this every year in the CEO survey. CEO said, critically important, we need data about our customers and clients' preferences and needs. We need financial forecast and prediction. We need data about our brand and reputation. We need data about the risks to which we are exposed. 95% of CEOs are saying that. 92, 92, 93. How many are getting it? 21%? 41%, 24%. So even though our companies and our businesses want this better data, we are nowhere close. This is a massive gap here between wanting it and getting it. We kind of suck at better, right, when it comes to data. How are we at getting faster? This is what happens in 60 seconds on the internet, 2018 to 2019. This is how fast the world is happening. In 2018, 38 million messages on WhatsApp, 2.4 million steps, 266,000 hours of Netflix watched in 2018. This year, 694,000 hours of Netflix watched. 1.1 million Tinder swipes here, 1.4 million Tinder swipes here. I'm guessing mostly right because the Netflix number just keeps going up and up and up. I know how old you are based on who left. But the point being, the world is getting so much faster. When you ask CEOs, how do you feel like you're keeping up? Do you feel like you are innovating? Overwhelmingly, the answer is no. And that skills gap of being able to get people faster, to get their brains to go faster, to get skilled up, we're falling behind. We can't innovate, our costs are rising, our quality standards are slipping, we can't pursue a market opportunity, we're missing our growth targets. So we're not getting better, and we're not getting faster. In fact, we're falling behind further and further. So are we at least getting cheaper? Are we at least saving some money? Huge surprise, no. In the next 12 months, CEO priorities, operational efficiencies. This is where they are looking for revenue growth. Operational efficiencies is code for cutting costs everywhere, right, including headcount. CEOs are saying, we've got to find revenue somewhere. Let's get rid of a bunch of people. Hopefully grow our revenue organically. Maybe launch a new product or service, and then exit. And what we see globally, it doesn't take an economist to figure this out. Global confidence in growth is down, substantially down. Pick your reason, depending on your political persuasion, it could be any number of things, but the numbers themselves say the money coming in is going down, and our confidence that's going to keep going down is lower. So we're not better, we're not faster, we're not cheaper. What does that yield? That gets us to not a great situation. The solution, unsurprisingly, which is the reason you're here, is to look at deploying artificial intelligence solutions as part of that operational efficiencies, as part of that organic growth, as part of better, faster, cheaper. How do we do that? AI delivers on 3 key promises: acceleration, accuracy, and automation. Acceleration, make things go faster. Makes everything, anything you can possibly do to get the business to move faster. Whether it's something as simple as condensing a report down to a couple of bullet points, whether it is as complex as improving customer service, speed time, response times. Accuracy. Humans suck. Humans suck at accuracy because our brains are not wired for math. Our brains are actually wired for something completely different, for sort of abstract imagery. Right? It's where we're really good at like spotting a lion, but if the lion's behind us, we'll just get whacked in the head. And automation. Let's stop doing boring shit. Right? How many of you have at least one task per week that is repetitive, is relatively low value, and you hate doing it? Right? Almost every hand should be up, unless you are an amazing human being, that or you just do God's work, whatever. What does leadership think about AI? Everybody on the planet is thinking that it will have a larger impact than the internet. And by the way, we are obviously here in North America, we're in Chicago. It is fascinating to me that in all of what you would consider sort of the emerging markets, developing markets, whatever, there is more belief in AI and the willingness to implement it than there is in North America. This number down here, that disagrees strongly, shocks me, because all of these other regions see it as a competitive advantage to take leadership. So what is this stuff? Why are we here? The joke online is, if it's in a PowerPoint, it's AI. If it's code, it's machine learning. Right? Artificial intelligence is nothing more than getting machines to do cognitive tasks that normally humans can do. If you have kids, if you are a kid, you've had this progression of building up your cognitive capabilities. Harvard shows that pretty clearly. This is what happens as a human matures. Basic inputs, language development, complexity, and higher cognitive function. By the way, as a parent of a teenager, I appreciate the fact that the Harvard chart drops off right around the MP. Cognitive function goes right out the window. But our machines are not so different. In the beginning, you have the basics, basic math, algorithms, machine learning, deep learning, and then what everybody is either hopeful or afraid of, general purpose AI. When you have artificial general intelligence, people think Skynet and Terminators or WALL-E or whatever. But that's a long ways off, probably at least 5 years. All artificial intelligence begins with statistics and probability. It is math. AI is math, not magic. AI cannot create something that is net new. It can only work on stuff that's already been given. When you take a bunch of math principles together, you get algorithms. An algorithm is nothing more than a process which has a clear output. And you use them every single day in your business, in your life. I would wager you a pastry retail value of $5 or less that you probably put on the same article of clothing every single morning. Right? Some people put on their top first. Some people put on their bottom first. A few weirdos put their socks on first. But you do it in a repeatable process that yields a known outcome. That's an algorithm. Up until this point, most of the software you've used is what's called traditional software, where people took algorithms, took code, and it creates an output. So we write the code, and the machine spits out the data. Everything from playing Candy Crush on your phone, to spreadsheets, to Cognos, all based on traditional algorithms. Where things have changed is with what is called machine learning, where now, instead of we build the code and it does the work, we give the data to the software writes its own code, and then it executes on it. So to give you an example of what this looks like, imagine you have a table full of blocks and you wanted to do something with this block. So either you wanted to find something or you want to organize it. If you want to find something, you'll be using what is called supervised machine learning. And supervised machine learning is just teaching the machine over and over and over to recognize a certain pattern, the color red. You show it a million photos of the color red, and eventually the machine can figure out this is the color red. Now this can actually be misleading at times for the machines, but for the most part this works really, really well. The most popular example of this is from 2013. University of Tokyo, a woman was suffering from leukemia and was not responding to treatment. What happened was the doctors were trying to treat her and she just didn't respond. So IBM's oncology team took this woman's genome, sequenced it, fed it to Watson. Took 233,000 oncology journals, fed that to Watson, and said to Watson, figure it out. Right? We have a known outcome, supervised learning, figure out what's wrong. Watson did it, figured it out that they were treating the wrong kind of leukemia. There was a misdiagnosis. They changed the treatment, she made a full recovery. Now that in itself is pretty cool. What's even cooler is that it did it in 11 minutes. Better, faster, probably cheaper. That's supervised learning. Unsupervised learning is when you have this pile of blocks. Maybe you don't want just the color red. Maybe you have a table and you want to organize it. You want to organize that by colors, by shapes, by sizes. We can do that. You can do that pretty easily looking at that picture. Now imagine a room full of blocks, right? You suddenly stop being able to do that in a timely manner. The machines can do it much more capably. Example of unsupervised learning. I was getting ready for a client meeting and I didn't pay attention to my calendar, and I had to tell this client what was happening in 2,600 articles in the press about them. Like, well, let's use a process called topic modeling to extract out what are the common themes in these articles. Software did it in 5 minutes, had one chart, and I was able to make it to the client meeting and get a cup of coffee on the way because the machines did it better and faster than I did. So that's unsupervised learning. There's this term that you've probably heard called deep learning. Deep learning is nothing more than taking a bunch of these machine learning techniques and stacking them together like pancakes. And then instead of syrup, you have data going from layer to layer to layer, being transformed along the way until what you get at the bottom is outputs that are better, faster, and cheaper than what humans can do. If you've ever used, for example, the Google Translate app on your phone, up until 2016, Google Translate sucked. It was a terrible piece of software. It gave like weird word salad answers. So what Google did was they took all 105 languages that they knew, and they said to DeepMind, its deep learning networks, figure out how human language works. What it did was, instead of trying to translate English to French or Dutch to Spanish, it translated from English to a machine encoding of human language. So English to Google to Swahili, Russian to Google to Xhosa. And the translations were so much better because Google figured out that you can reverse engineer all human language that have these commonalities and make much better translations. For those of you who are Bible scholars, we are reverse engineering the Tower of Babel. We'll let you decide the wisdom of that. So this is the hierarchy of machine learning. Stats and probability, algorithms that lead to machine learning, that lead to deep learning. Now why do you need to know this? Right? Do you need to know this? I don't expect anyone to become a machine learning expert or an engineer. But as you do business, almost every vendor you're going to run into in the next couple of years is going to say, we have AI in our product. Even though 35% of them, according to the Financial Times, when they did an investigation, 35% of vendors that said they had AI in had not a scratch, zero, nothing. So you need a familiarity with the concepts to build what we call a detector of, a Spanish called excremento de toro. When a vendor is saying something, you need to be able to ask deeper questions. Okay, what kind of machine learning do you have under the hood? How does it work? What are your training data sets? So you want this familiarity. The state of the art, where machine learning and AI is going, was demonstrated by IBM this February at IBM Think. They put a human debate champion on stage. They put Project Debater. It's really funny. They have this like black monolith here with flashing lights. But when you talk to the Project Debater, you're like, yeah, that's just a bunch of lights in a plastic box on stage. There's nothing actually in that box. It just needs to blink because no one's going to look at a server farm. And they gave the two contestants 15 minutes in advance the topic. Your topic is justify the subsidization of kindergarten. No prep otherwise. Both contestants had to come up with arguments, deliver opening statements, and then listen to each other, rebut each other's opening statements, and then deliver closing statements. And the machine, Project Debater, did this in real time. It listened, it transcribed, it analyzed, it pulled together new arguments from its data source, and created a very credible debate scenario. So that's state of the art. That's what is possible today with this technology. But there's some things that the machines can't do. The machines are really bad at empathy. We define empathy as knowing what someone else is going through and being able to act on it. Machines can't do that. They can analyze, but they can't take action. The same is true of judgment. Machines have no judgment capabilities. Judgment, but I mean, like when you go to a restaurant and you sit down and you greet the server pleasantly, as opposed to, what most people do is be rude or abrupt. If you greet the server pleasantly, maybe the server brings you an extra appetizer because they like how you interacted with them, right? That is human judgment, overriding a rule. By default, machines cannot override rules. They are the rules. So they're bad at that. Machines are bad at general life experience. They cannot cross domains easily. And they're really bad, actually, at very specific domain knowledge. So that deep experience, that lifetime experience that you had is very difficult to replace in a machine. And for the most part, machines are bad at human-to-human relationships. For the most part, most of the time, we want to deal with other people. The exception is that if our customer experience is so awful that we'd rather deal with a machine instead. Any of you not from the United States here? Is everyone from the United States? Okay, we have this thing called the Department of Motor Vehicles here. That is a hideous experience. We want them all to be replaced by machines. So let's look at some practical examples. 5 problems that artificial intelligence solves really well. Untapped data, unknown entities, unclear analytics, unfocused data, and being unprepared for the future. The first, dealing with unstructured data. We have a ton of untapped data in our organizations, tons and tons and tons of it. This is emails, phone calls, documents, chats, any kind of interaction where there's not, basically it doesn't fit in a spreadsheet. That's unstructured data, and we have tons of it, and we're not making use of it. For the most part, we just kind of ignore it. It just kind of gets quarantined somewhere. We did a project for a truck driving recruiting company this year to help them understand why they were recruiting fewer drivers. So on the one hand, we took all of the job listings that they put on Indeed.com. There were like several thousand of these. And we used natural language processing to figure out what are the words and phrases that are the most prominent in their job listings. Class CDL driver, commercial driver's license, requires this, valid class, all the decorations that they have for truck drivers. This is the language that the company used in its job ads. Then we took 17,000 audio calls from their call center, had AI transcribe them, and analyze them. What did the drivers talk about? Paying for cents per mile, starting cents per mile. I'm going to be home on the weekends. What holidays? What type of load am I carrying? So on the one hand, you have what the company cares about in their job ads. And on the other hand, you have totally different language that drivers are speaking to operators. Like, of course your applications are down. You are not saying a single damn thing in your job ads that the drivers want to hear about. So of course people are like, well, this company clearly has no interest in me, the driver. I'm going to go somewhere else. So by providing them with an insight, we can say, you need to change your job ads. Your job ads now need to reflect the language that people used to speak to you in order for you to improve your business. Second case study, unknowns. We worked with a food and beverage company, and we took their inbox, their customer service inbox. They had tens of thousands of emails a month from customers saying, hey, do you have this? Could you do this? Et cetera, et cetera. And our remit was, help us find the white space. Help us find what we don't know the customers are asking for. So we did a whole bunch of mining about every word and its relationship to other words within their email inbox. And what we found was this. There were 2 beverages. This company makes stabilizers. There were 2 beverages they'd never heard of. Oat milk and hemp milk. I didn't even know you could make milk out of hemp. They just smoked it. These are multi-billion-dollar product lines because the stabilizers that are on the market are desperately needed in order to turn them into something drinkable that holds, doesn't immediately separate when you pour it in a glass. And so by using, in this case, both natural language processing and network graphing, we found things that their customers were asking them for, but they didn't know was a thing. Third example, we have a lot of data. How do we know what data to pay attention to? This is an example of a technique called RFM analysis, which stands for recency, frequency, and monetary value of customers. We're working with a company that makes oil, and they said they need to understand how the different customers behave. So we make this 3-dimensional cluster using a technique called clustering to look at these 3 dimensions and say, you are spending all of your time trying to please this cluster 3, this customer here. They were spending all their time there. This is the low value, low frequency, low recency customer when they were not paying nearly enough attention to cluster 4, the high value, high frequency. By changing their focus, who their account managers were assigned to, you assign your best account managers to the people that are the most profitable customers, totally changed how this business looks at evaluating somebody when they walk in the door to be more profitable just by doing the RFM analysis with machine learning instead of just the traditional way of doing it. The fourth example is a marketing example. My background is marketing. One of the questions that we struggle with most as marketers is, how do we know what's working? How can we give credit to what's working? How do we know where somebody is in the customer journey? Everyone who's done digital marketing these days has experience with SEO, with Facebook, with Twitter, with text messaging, with email. You've probably seen or used these things. But what's unclear is, in what order does something need to happen in order for a customer to feel like you're paying attention to them at the right time? Because someone can be in more than one spot in the customer journey. I was at Forever 21. I was in the local mall, and I was watching this kid on their phone asking their friend via video, hey, how does this thing look on me? And their friend gave them feedback, and then this person said, okay, I'm just going to go buy it on Amazon. So this person's in multiple different customer journeys at the same time, right? All of our customers are. So in this example, we took this for our website, every single thing that somebody did, and using a machine learning technique called Markov chain modeling, figured out how does somebody become a customer, from becoming aware of us, to interacting with us, to finally saying, yep, I'm raising my hand, I want to do business with you in some fashion. We see organic search. When people search for topics about us, is a major driver of the conversion. So is speaking. Social media, we classify that there. So is our email newsletter, but that's towards the end of the journey. Now with this information, we could do something like, well, if we are saying in our social media channels, buy now, there's a sale on these reports, but social media is way over here in awareness. It's like, going on that really awkward first date where somebody says, let's go home. Like, no, just have coffee. Messaging mismatch, right? If it's at the beginning of the journey, I should be helping you understand who the heck we are, not trying to sell you something. You sell somebody something when they're on this end of the journey. So this is an example of driver analysis. How do we figure out the sequence in which somebody wants to be sold something? Equally true, on our website, this is my personal website, what are the pages people visit on the way to a conversion, on the way to buying a book or something like that? By using machine learning, we can figure out these are the pages that someone visits that more often than not push them over the line to convert it. And by knowing that, I can change my tactics. I can change what I advertise, what content I write about, what I feature on my website. It drastically changes your business. Finally, forecasting and predicting. My CEO, Katie, just gave a 40-minute talk on this, but we'll cover briefly. You can use machine learning and an existing data set to predict what's likely to happen next using math. This is an example looking at mortgage complaints. People who complained, filed complaints with the Consumer Finance Protection Bureau. And the Bureau tracked, the resolution was the company had to pay money out to the customer. And up until this line was what was happening. And then using predictive analytics, using time series forecasting, we can now forecast forward. These are the likely settlements you're going to have to make. Now, if you give this to a mortgage resolution company, or a mortgage company, they can say, okay, we need to likely block off this amount of money, just earmark it in the budget for next year immediately, because we're probably going to have to pay that much in settlements. So you can make sure you don't have budget surprises. But also, you can then use this data and say, well, what about complaints where there was no monetary relief? Once we got past the Great mortgage crisis of 2009, there's a very clear cycle of complaints. So if we can anticipate those complaints and staff up appropriately and change our messaging, we can reduce the complaints that result in monetary relief. We can save ourselves money by anticipating complaints and staffing up appropriately. The same is true for complaints with explanation. If you were this company, you would know that right around this time, this is about January, by the way, of this coming year, you're going to have more complaints. Staff up appropriately. Have the right resources. So predictive analytics lets you forecast in advance and say, I know what's likely to happen, and I can skate ahead of it. So those are 5 examples of the way that you can use machine learning and artificial intelligence today. These are not theories. This is not navel-gazing. This is stuff that is in production that's accessible to you. The key to this is to start now. Remember, machine learning is all about feed the data to the machine, it writes its own code. The more data you have to feed it, the better it writes its own code. Which means that the longer you wait to start, the less time you have to be able to gather that data, especially for competitors ahead of you. So how do you get started? 7-step process on the journey to AI. First step, you need a solid data foundation. This is where 90% of companies start and end their AI journey because they can't find their data. Because we had one customer, they weren't even allowed to access their own data for these weird internal regulatory environments. They had some issue going on, but they weren't allowed to use their own data. They actually had to hire us to get data about them, to them, for them. But if you can have that data foundation find, clean, prepared, and unified, you're ready to move on to the next step. The next step is to become measurement-driven, become an analytics-focused company, a data-driven company. Most of you, I would guess, are already that, because you wouldn't be here learning about things like business analytics if you were just a hot mess, right? You at least know what KPIs are and know that you need to make decisions based on data first. Third is qualitative capabilities. You need to have the ability to do qualitative research because no analytics solution at all in market right now can tell you why somebody did something. Why did you abandon your shopping cart? Why did you complain? Why did you buy less than we thought? We don't know unless we ask people, why did you make that decision? Right? Why did you walk out of the store? Only through qualitative research can we determine that. The 4th step in the journey is process automation. One of the most important things you can do is to free up time. Machine learning and artificial intelligence and data science, these are professions. It's like surgeon or chef, right? These are real professions that require a lot of time and expertise. So if you want to build those capabilities in your company, you've got to free up people's time. So automate as much as you can, even through traditional methods. Now it's at this point where you have a decision to make. Are you going to be applying machine learning and data science to your core competency as a company? Or are you just looking for some efficiencies and you want somebody else to build it? If, no matter what, these next 3 steps will happen, but it's a question of whether you will do them or you'll have a vendor do them. So data science, being able to explore the unknowns, build statistical and math capabilities, code and engineering to answer questions about your data. Machine learning is when you take those findings and turn them into real software, process automation, advanced, all the types of machine learning we talked about. And eventually you aspire to being an AI-first company where you say, I want to solve as many problems with AI as possible. There are only a handful of these companies on the planet. Right? You probably know all of them by name. Google, IBM, Microsoft, Amazon, Facebook. Right? Everybody else is not there yet. So how do you buy or do you build? It's a question of time, money, and strategy. If you have time and you don't have money, you're building it. If you have money and you don't have time, you're buying it. And if it's your core competency, you're building it. Because the last thing you want is your company being held hostage by a vendor for something that is your core competency. You have to build that in-house so that it is part of your secret sauce. If you're going to buy it, the good news is there are tons of applications out there already, and many of them are very practical and easy, simple use cases that you can pilot. This is an example of one. This is a company called Otter. Otter, like the animal, otter.ai. All you do is give it audio files and it transcribes them. I have a terrible memory for conference calls, right? Because I typically fall asleep around minute 7. I record the calls with permission, feed it to Otter, and then go back and read the transcript of what happened in the call while I was asleep. You can use this for phone calls, for meetings, of conferences. We've got these audio recorders here. Everything that I'm saying right now is going into that recorder, and then I'm going to go and have Otter turn it into text that I can use for books and papers and all that stuff. AI is going to find its way into your products and services anyway, from your customer service applications, your marketing applications. This is Google Analytics, which measures your website. There's a button up on the right-hand corner called Insights. All it is AI. It's Google's machine learning to say, hey, we noticed something weird about your website. You might want to go have a look. There's even a little Ask Google thing here. All the major tech vendors that use smart speakers and smart assistants are rolling out business-level applications now. You can actually connect, I saw this at Think, you can connect Alexa to Watson and connect Watson to Cognos, and then ask Alexa for the reports from your Cognos dashboards. It's a long wiring process, but it is possible. So that's stuff that you can buy today. If you're going to build it, the best platform for most people, for most applications, is IBM Watson Studio, because it offers multiple different ways for you to get to production models and then take them into production and not have to do it, the full code building. If you like building code, if you like running code, these are the two programming languages that we want to look at: the R language environment and the Python language environment, both of which run inside Watson Studio. So again, if you don't want to spend $10,000 on a really fancy laptop, you can do it within IBM's ecosystem. Now, where are things going to go wrong? Your first projects will almost certainly screw up. They're going to screw up very predictably. The first place your projects will go wrong is in business requirements and your analytics approach. The number one thing people do wrong is they have a CEO who comes to them and says, we need to put some AI in this product. Like, no, that's not how that works. You need to have a business problem that AI is good at solving. Better, faster, cheaper. Right? Not creation, not ideation, not customer relationship, all the things AI is bad at. Tech for tech's sake is the worst possible idea. Second thing that's likely to go wrong here is data requirements. Data requirements is a fancy way of saying technical requirements. What do you need to have in place in order to be able to do the project successfully? I screw this up all the time. It's like I have an idea, like I'm going to go build some code and do a thing, and I show it to my CEO, and she's like, well, did you think about this? I'm like, shit. No, I didn't. I have to start all over again. So being able to focus on the data requirements piece and solving for that, asking yourself over and over again, what can go wrong with my data, will save you so much heartache. The third thing that will go wrong, model selection and model evaluation. If you don't have a qualified data scientist either on staff or at your vendors, you will waste a tremendous amount of time with substandard models, because they will not know beyond a certain basic best practices what model to choose. There's so many different ways to solve any given problem in data science and AI. So this section here, now there are some offerings. There's a brand new offering from IBM called Auto AI, built into Watson Studio, that can help with model selection. It actually does the testing for you and evaluates a couple hundred models at a time and tells you which one performs best. And the fourth area where things go wrong is in deployment and tuning. Most people think, okay, we did the project, we deployed the model, we're in production, great. Let's move on to the next thing. And they just kind of leave it. And you get this thing called model drift, when the model stops behaving well and does something else. The most famous example of this is Microsoft's Tay Twitter bot. I don't know who I thought this was a good idea. They put this Twitter bot that would interact with other users on Twitter, and people could converse with it. And in 24 hours, the internet turned into a racist porn bot, because nobody put any guardrails on it. No one tuned it. No one made sure it was behaving properly. And of course, very, very few people do good after-action review. So how do you prepare your company for AI? You're going to need three kinds of people. The popular expression from 2006, data is the new oil, and it is. That's a great analogy, because if you've ever seen crude oil, it's nasty, sticky, tarry, disgusting stuff that does very little by itself. You need people who can take that data from where it is, like oil, and extract it out of where it's living. Those would be your developers. You need data scientists, people who can take that raw product, refine it into something, into models, into outputs, and then you need technologists, marketing technologists, IT people, to bring that product to market some way, internally to your own internal customers, or maybe directly to the market. So those are the kinds of roles you'll need in your company. Now, if you're working at a larger company, you're going to do this in order. Developers first, then data scientists, then your technologists to deploy. If you're a smaller company, you'll go in reverse, because there are enough easy wins on the deployment of existing technologies that you can raise some revenue to afford the rest. And now the part people always wonder about: who's going to lose their jobs? AI doesn't take jobs. It takes tasks. And a job is a collection of tasks. Right? Every single job is a collection of tasks. And individual tasks that are highly repetitive will go away. If you were to pull open your calendar right now and look at the third Monday in December, and you know for sure, without a doubt, everything's going to happen that day, then yes, your job is a collection of tasks that are so predictable that 5 months out you can predict what you're going to do that day. That is a job that is at risk. On the other hand, if you open your calendar and it's what? It's Wednesday and you have no idea what's going to happen Friday, except it's going to be juggling flaming chainsaws all day, your job is relatively safe from automation. To ensure that you're further insulated, you need a bunch of things. Number one, you need multidisciplinary skills. According to LinkedIn, in this here, these are the top 10 skills that the market is looking for. Again, in any of these disciplines, there are a bunch of tasks that can be automated, but if you are good across disciplines, if you're good at sales leadership, and you're good at video production, and you're good at people management, you are very difficult to replace, as opposed to being good at just one thing. You need to think algorithmically. Learn to think like a machine. Now, it doesn't mean you need to be a coder, but it means you need to approach every problem you have and say, can I solve this problem with a system that makes the problem go away forever? As opposed to, I'm going to solve this problem right now just to get off my plate, and next Wednesday I'll be back on my plate again. Solve the problem once and for all. Third, you need to learn how to oversee the machines. This is a career in and of itself. Machine learning is math based on patterns, and those patterns can be deceived, or they can be biased, or they can be corrupted. Classic example, last year Amazon created an AI to screen resumes and stop hiring women, because they trained it on past data that was 96% guys, and their AI said, well, let's choose guys, because clearly that's what the pattern was in the past. Well, that's a bad outcome. Right? That is not an acceptable outcome. So we needed to oversee that machine. Another fun example from facial recognition. Facial recognition is based on things like edge detection, which means that if you have this lovely, insane clown posse makeup, facial recognition can't recognize you. It just has no idea what to do. A third example, this is technology called deepfakes, the ability to map someone else's face onto another person. This is much more of a question of ethics, right? Ethics in AI is going to be one of the most important jobs in the next 5 years, because without it, your machines will do things that you never wanted them to do, and it will get into enormous amounts of trouble. Fourth, we need to become outcome-focused as professionals. This is the cheat sheet for running Keras and TensorFlow, the architecture from deep learning. I used to have this hanging in my office, and I would check off one thing at a time as I tried to slowly learn this very painful framework. And I went to IBM Think 2018. They said, that's stupid. Why are you doing that? Use Watson Studio and just drag and drop the pieces together. And I'm like, well, shit. There goes 18 months of my life I'm never getting back. I went to Think this year, and they said, oh, we don't do that anymore. Now it's auto AI. Just drop your data set in, and it'll do it, and then you just inspect the outcome. Like, stop doing this, because at some point I'm just going to stop coming. So where's stuff going? Look at the number of companies on this side that have started AI initiatives, either testing the waters, in production, or mission critical. Western Europe leading the pack, then North America, then APAC, Latin America, Central Europe, Middle East, and Africa. Isn't it fascinating? It is fascinating to me that the same number of countries of companies in Africa that are doing AI is equal to the number of companies that say they have no plans to in the US. Right? Where things are going is that as a country, as a nation, as a region, there's a global competition for AI. Right? And whoever gets there first is going to win outside rewards. Why? Because the machines are really, really good at what they do. This is an example of a machine learning algorithm called GPT-2 from OpenAI, General Purpose Transformer number 2. Fed a bunch of language, it can write net new language from new Harry Potter novels with moderate success, new tweets, new social media content at massive scale. I trained it on 10,000 Twitter chat questions, and then once it finished its training, it took about 3 hours, I was able to generate 20,000 tweets a minute. And they were all really, really good. I took another set of tweets from a famous politician who's prominent on Twitter, and I fed that person's tweets into this thing, and I had it try writing a whole bunch. I told GPT-2, I want you to declare war on North Korea. And it wrote 10,000 tweets that are perfect in the tone, the syntax, the weird capitalization, everything. Did it perfectly. The machines can do this. So in the future, there are going to be two kinds of jobs left. Either you are going to manage the machines, or the machines are going to manage you. That's it. So you have to decide which side of that you want to be on. Do you want to be the one running the machines, or do you want the machines running you? And by the way, the machines already run you. Because the first thing most people check each day is a machine. It's that little black mirror in your pocket, right in your bedstand. So decide quickly, where do you want to be? With that, thank you very much.
Want help solving your company's data, analytics, and digital marketing problems? Visit trustinsights.ai today and let us know how we can help you.